Hello, hello, hello. So welcome to Module 3, Part 2, uh, Introduction to the Mole. So in Part 1, remember how we mentioned a problem, which was if you had 60 grams of carbon and you divide that by its molar mass, 12, you'd get 5 moles of carbon. Because remember, 12 grams of carbon is equal to 1 mole. So the molar mass of one element, that's so ugly, but molar mass of element is equal to 1 mole. So we have pretty much 5 times the molar mass of carbon, so that's why we'd have 5 moles. So in this video, we're going to introduce the Avogadro's number. What is Avogadro's number? So you could see down there that the number for Avogadro is 6.022 times 10 to the 23rd. But what does that mean? So when you have 1 mole, well, per se, 1 mole of carbon, then you have 6.022 times 10 to the 23rd atoms. So if we were to go to 1 mole of nitrogen down here, we'd also have 6.022 times 10 to the 23rd atoms. And if we were to go to hydrogen, when you have 1 mole of hydrogen, you'd have 6.022 times 10 to the 23rd. So all of these have things in common because even though they differ, because they're different elements, they have 1 mole, which equals to 6.022 times to the 10 to the 23rd. So that's another point that needs to be made. When you have 1 mole of any element, it'll equal to 6.022 times 10 to the 23rd atoms. My bad. But when you have this number, you'll have atoms. So when you have 1 mole of any element, you'll have 6.022 times 10 to the 23rd atoms. So going off of the problem we did in part 1, well, uh, actually, if you have 1 mole of carbon, if you have 12 grams of carbon, how much atoms would you have? How would we calculate that? So, for when you have 12 grams of carbon and you want to find a mole, you have to divide it by the grams by the molar mass. So, which is 12 grams, which gives you 1 mole. So, 12 divided by 12 is 1, right? Then, as we discussed, 1 mole of any element is equal to 6.022 times 10 to the 23rd atoms. Atoms of carbon. So, put that in your calculator, calculate that with me, and I'll give you a little time to do the calculation and we'll talk about the answer. So, if you multiply 12 times 6.022 times 10 to the 23rd, and you divide that by 12, because remember, 12 is the molar mass, then you'd get 6.022 times 10 to the 23rd. Does that make sense? So, for our particular problem that we did in part 1, let's do it up here. If we're given 60 grams of carbon, you divide that by the molar mass, which gives you 1 mole. Well, for 1 mole of carbon, it's 12 grams. And in 1 mole of carbon, we have 5 in this case, because remember 60 divided by 12 gives you 5 moles of carbon. So we write that there. And on 1 mole of carbon, we have 6.022 times 10 to the 23rd. So if we're to calculate all that, which I'll give you time for, how much atoms would we have in 60 grams of carbon? So 60 times 1 times 5 times 6.022 times 10 to the 23rd divided by 12, the molar mass. And then you can multiply the ones, but it doesn't really do much. So you multiply pretty much the top row by the bottom row. When you do that, you get 1.50 or 1.5 times 10 to the 25 atoms of carbon in 60 grams. So what we did here is we went from grams to moles to atoms. Pretty cool, huh? Let me erase some of this stuff. Now, what if we want to go to, let's say, protons, from grams to protons? Well, let's use our following example again. So 60 grams of carbon divided by the molar mass of carbon, which is 12 grams, will give you 1 mole of carbon. Well, my bad, I'll give you 5 moles. But in 1 mole gives you have 12 grams. So once you do that, you have 5 moles. And then for every mole, you have 6.022 times 10 to the 23 atoms. Here, I think it'd be pretty handy to have your periodic table with you. So let's look at carbon in the periodic table. Carbon has 6 protons because it's element number 6. So in 1 atom of carbon, you have 6 protons. So if we're to do all this, so you multiply the top row, 60 grams times 1 mole times 5 moles times 6.022 times 10 to the 23rd atoms times 6 protons. Then you divide by the bottom row, which is 12 grams, and then you can multiply the ones, but pretty much by 12 grams. So top row divided by 12, what would you get? So once you do that, you get 9.033 times 10 to the 25th protons. Pretty cool. So these kind of problems where you're converting from different units from grams to moles to atoms to even protons. This is what you'd call stoichiometry. My bad. So in this video, we talked about Avogadro's number, which is 6.022 times 10 to the 23rd. We discussed how for 1 mole of any atom, of any element, you'll have 6.022 times 10 to the 23rd atoms. We talked about converting from grams to moles to atoms, as we did over here. And we talked about converting from grams to moles to atoms to protons up here. Oh, my bad. So that wraps up this video. We'll have a part 3. Like, comment, and subscribe the Peer Leader channel. Thank you very much and enjoy your day.